Hi, welcome to the 15th International Conference on Applied Human Factors and Ergonomics and affiliated conferences at Nice, France. In this tutorial on toward data science modeling techniques in predictive analytics with Python. Today our primary focus will be on predictive analysis, a powerful tool for forecasting future events and trends. We will explore the fundamentals of data science and highlight its significance in predictive analytics. Next, we will discuss Python and its robust libraries and understand how they contribute to the predictive modeling process. Get ready to learn, engage, and enhance your knowledge. Overview of the tutorial. Introduction to the data science. Start with the fundamental concept, setting the stage for the more specific topics that follows. Understanding the predictive analytics. Build on the data science foundation by introducing a key application area, showing how it fits into the broader context. Applying Python in predictive modeling. Moves to practical tools and techniques, detailing how Python supports the concept introduced earlier. Case study, practical application. Concludes with a real-world example demonstrating how the discussed concepts and tools are applied in practice. My background at a glance: 22-year plus experience, founding campus director, 25 plus conference paper. I have organized 2 international conferences and conducting tutorials in AHFE since 2016 and have some funding project. This is my qualification. What is data science? Data science involves extracting knowledge and insight from structures and unstructured data using scientific methods, processes, and systems. Key components: data structure, gathering data from various sources to initiate the analysis process using database, APIs, and web scraping to fetch data for analysis. Data cleaning, ensuring data quality and consistency by identifying and rectifying errors and inconsistencies. Handling missing values in a customer database. Data analysis, interpreting data using statistical and computational techniques to extract actionable insights. For example, analyzing customer purchase pattern to identify trend. Data visualization, communicating insights through graphical representation to facilitate understanding and decision making. Example is using bar chart to show sales performance across regions. Introduction to data science. Definition: data science integrates scientific methods, algorithm, and system to extract insight from structures and unstructured data, as I already said. It is an interdisciplinary field, combines statistics, machine learning, and computer science techniques for data analysis. Growing demand of storage. Increased demand, the advent of big data has significantly increased the need of storage capacity. Impacts: discuss how organizations are coping with the storage demand posed by the large volumes of data. The significance of data science in AI. Role in AI highlights the critical role of data science in driving advancement in AI. Feature relevance: explain why understanding data science is crucial for future projects and business strategies. Understanding data science. Functions: explore its function in analyzing, mining, managing, visualizing, and sorting data for informed decision making. Applications: illustrate how data science supports predictive analytics and machine learning in various industries, which is our topic. The nature of data science. Field of study: emphasize data science as a multidisciplinary field that extracts meaningful insight from unstructured data. interdisciplinary methods highlight the use of scientific methods, algorithms, and systems from statistics, machine learning, and computer science. Enterprise data discuss the vast amount of data handled by modern enterprise data warehouse, enhancing decision-making capabilities. Summarize the key point cover interdisciplinary nature's role in AI, function, application, and impact on enterprise data management or data science application and its evolving role in shaping future technological advancement. The life cycle of data science discovery ask detailed questions about the project. What is the problem we are trying to solve? What are the expected outcomes? Verify resources. Do we have the necessary data, tools, and technologies? Is the timeline realistic? Gather business issues, understand business problems, and create an initial hypothesis for testing. A retail company wants to predict customer churn. The discovery phase involves identifying relevant customers' data, understanding the business context, and formulating initial hypotheses about why customers leave. Data preparation, explore and clean data, handle missing values, remove duplicates and correct errors, transform data, normalize and scale data is needed. ETLT, extract, transform, load and transform, load data into a sandbox environment for further processing. Use R for data cleaning. Python, you can write script in R to clean and visualize data. In the customer churn project, gather data from different sources, transactional behavior, and clean it to ensure consistency. Model planning, determine relationship between variable, use correlation metrics to find significant variables. Apply EDA exploratory data analysis, create visualizations to understand data distribution and patterns. Tools SQL for data manipulation, SAS for statistic analysis, R for visualization. Visualize customer purchase pattern to identify features that might influence churn such as a purchase frequency or average order value. Model building, develop database for testing and training, split data into training and testing sets, analyze learning method, evaluate algorithm like logistic regression, decision tree and clustering method. Validate tools, ensure the chosen tools are appropriate for the model. Tools, MATLAB for algorithm development, statistics for statistical analysis, Vika for machine learning, Alpine Miner for advanced analytics. Build a logistic regression model for predict customer churn and validate it with the data set. Operationalize, distribute reports and codes, share findings and technical details with stakeholders, release pilot projects, test the model in a real-world environment with a limited audience, assess performance, monitor the model's accuracy and performance before full deployment, implement the churn prediction model in the company's CRM system and monitor its performance for a month before full rollout. Communication result, check if initial goals were met, compare the result with the initial objectives, communicate with the stakeholder, present the key finding and their implications, assess project success, determine if the project was successful based on predefined metrics, present the reduction in churn rates to company executives and discuss potential improvement based on model performance. The life cycle of data science. Advantages of data science. Versatility. Data science finds applications in consultancy, healthcare, e-commerce, and banking, among other fields due to its ability to analyze and derive insights from data across diverse domains. A consultancy firm uses data science to analyze market trends and consumer behavior across different industries, providing tailored insight to client for strategic decision making. Automation of boring tasks. Data science automates tedious tasks such as the data entry and calculations, freeing up human resources for more creative and strategic roles. In a retail environment, automated predictive analytics can optimize inventory management by forecasting demands based on historical sales data, reducing manual inventory check. Abundant job opportunity. There is a significant shortage of skilled data scientists relative to demand, creating numerous career opportunities across various industries. A technology company hires data scientists to develop algorithms that improve the accuracy of personalized recommendations for its user, enhancing customer satisfaction and engagement. Enhance data quality. Data scientists utilize advanced techniques to analyze and cleanse data, ensuring accuracy and reliability for decision-making process. An insurance company uses predictive modeling to assess risk more accurately, resulting in better pricing strategies and reduce claim losses. Impact on healthcare. Data science applications in healthcare include early disease detection, personalized medicine, and operational efficiency improvement. Medical researchers use machine learning algorithms to analyze genomic data and identify genetic markers associated with specific disease, leading to targeted treatment and improved patient outcomes. Prestigious role in business. Data scientists play a crucial role in shaping business strategies and driving innovation, making informed decisions based on data-driven insight. A multinational corporation employs data scientists to analyze customer feedback and market trend, enabling proactive adjustment to product offering and marketing campaigns. High demand globally. Data science skills are in high demand worldwide due to their ability to extract valuable insights from complex data sets. Government use data science to analyze economic indicators and demographic trends, informing policy decisions that promote sustainable development and social welfare. Disadvantages of data science. Domain knowledge dependency. Data scientists often require specialized domain knowledge to interpret data within specific industries or sectors accurately. A data scientist working in finance needs a deep understanding of financial markets and regulation to develop predictive models for investment strategies effectively. Data privacy concern. The extensive use of personal data for analysis raises concerns about privacy breaches and unauthorized access. Social media platforms face security for data privacy violation when user information is shared without explicit consent of security measures. Ambiguity in terminology. The lack of standardized terminology can lead to misunderstanding and inconsistencies in communicating data science concepts. Different organizations may use terms like data mining or machine learning differently, causing confusion among stakeholders and hindering collaboration. Tool selection complexity. Choosing the right data analytic tools can be challenging due to the variety of options available and their differing capabilities. A healthcare provider evaluates multiple data visualization tools to present patent outcomes effectively, considering factors such as ease of use, scalability, and integration with existing systems. Complexity of tools. Data analytics tools often have complex features and require extensive training to use effectively. As an e-commerce company invests in training its analytic team to use advanced statistics software for market segmentation and customer behavior analysis, improving targeted market efforts. Data science offers immense potential to transform industries and improve decision-making process through advanced data analysis. However, addressing challenges such as data privacy, tool complexity, and the need for specialized knowledge is crucial for maximizing its benefit and mitigating risk in practical applications. Advantages, disadvantage of data science, data analytics, types of data analytics, descriptive analytics. Descriptive analytics focus on summarizing historical data to gain insight into past events and trends. It answers the question, what happened? By analyzing descriptive analytics, organization can understand past performance, identify trends, and detect anomalies that require attention. Dashboards and scoreboard are common tools used in descriptive analytics to present summarized data visually. For instance, a sales dashboard can show monthly sales trends, regional performance, and product performance metrics. Diagnostic analytics. Diagnostic analysis delves deeper into data to determine why something happened. It aims to uncover relationship and pattern within data sets. It answers the question, why did it happen? This type of analytics help organization identify roots cause of problems or success, leading to more informed decision making and proactive management. Data mining techniques such as regression analysis, clustering, and correlation analysis are used in diagnostic analytics. For example, analyzing customer churn rates alongside demographic data may reveal insight into why certain customer segments are more likely to churn. Predictive analytics. Predictive analytics use statistical model and machine learning algorithm to forecast future outcome based on historical data. It answers the question, what is likely to happen? By predicting future trends and behaviors, organization can anticipate changes, mitigate risk, and seize opportunities before they arise. Applications include demand forecasting, predictive maintenance in manufacturing, and financial risk assessment model. For instance, a predictive model can forecast sales for the next quarter based on historical sales data, economic indicator, and seasonal trends. Prescriptive analytics recommends action to optimize outcome based on predictive models and simulations. It answers the question, what should we do? By suggesting optimal actions, prescriptive analytics guides decision making, improves operational efficiency, and enhances strategic planning. Decision support system and optimization algorithms are used in prescriptive analytics. For example, in supply chain management, prescriptive analytics can recommend the most cost-effective distribution routes based on predicted demands and transportation cost. Cognitive analytics leverage artificial intelligence and machine learning to simulate human thought process, enabling system to understand, learn, and make decisions autonomously. It enables automated reasoning and understanding of complex situations beyond what traditional analytics can achieve. Natural language processing, NLP, sentiment analysis, and image recognition are applications of cognitive analytics. For example, chatbots that analyze customer queries and respond appropriately use cognitive analytics for understand and generate human-like responses. Real-time analytics. Real-time analytics involve processing data instantaneously to enable immediate decision-making and action. It supports operational efficiency, real-time monitoring, and responsiveness of changing conditions. Streaming analytics and IoT data processing are common in real-time analytics. For example, in a smart city project, real-time analytics can monitor traffic pattern, adjust the traffic lights dynamically, and optimize emergency response time based on current conditions. Understanding these type of data analytics provides organization with a comprehensive toolkit for leveraging data to gain insights, make informed decisions, and drive innovations. Each type complements the others, forming a continuum from understanding historical data to predicting future outcome and prescribing optimal actions. By integrating these analytics types into business process, organization can improve efficiency, reduce risk, and capitalize on opportunities in today's data-driven world. Data analytics types, more details are coming slide. It's coming slide. Overview of predictive analytics. Predictive analytics is a core aspect of data science, focusing on using historical data to predict future outcomes, enabling proactive decision making and strategy development. The use of statistical algorithm and machine learning techniques to identify the likelihood of future outcome based on historical data. To make informed prediction about future events and trends using patterns found in existing data. Role of data science in predictive analytics. Data science play a crucial role in predicting analytics by transforming data into actionable insights. The process involves data collection, cleaning, feature engineering, model buildings, and evaluation. Predictive analytics is widely applicable across various industries and continues evolve with technological advancement. Data collection, aggregating data from manipulated sources to provide a comprehensive data set for analysis. Data cleaning, ensuring the accuracy and quality of data by handling missing values and removing inconsistencies. Exploratory data analysis, using statistical summaries and visualization to understand the data and identify patterns. Feature engineering, creating new features or modifying existing ones to improve model performance. Modeling, applying various statistical and machine learning algorithms to build predictive models. Evaluation, assessing model performance using metrics like accuracy, precision, recall, and F1 score. Deployment, implementing the model into production system for real-time predictions. Monitoring, continuously tracking the model's performance and making necessary adjustments. The process of predictive analytics. Data collection, gather historical data from various sources. Data preparation, clean and pre-process data for ensure quality. Model building, use statistical and machine learning techniques to create predictive models. Model evaluation, validate the accuracy and performance of the models. Deployment, apply the model to new data for making predictions. Data collection, gathering historical data from various sources. Quality and diversity of data significantly impact model performance. This involves collecting data that reflects past events or behavior which can be used to train predictive models. Source of data, data from various sources capture different aspects of the problem, leading to more robust models. Databases, structured data stores in relational or NoSQL databases. Logs, unstructured data from applications and system logs. Social media, text, images, and interaction data from social media platforms. Sensors, real-time data from IoT devices and other sensors. Transaction records, detailed data from financial and retail transactions. Data collection, gathering historical data from various sources. Quality and diversity of data significantly impact model performance. This involves data collecting that reflects past event or behavior which can be used to train predictive models. Consideration, accurate, consistent, and complete data ensures reliable and valid model predictions. Data relevance, ensure the collected data is pertinent to the problem at hand. Data volume, collect a sufficient amount of data to train robust models. Data variety, use diverse data sources to capture different aspects of the problems. For example, retail data collection, there is a transaction data, purchase history, amount, timestamps, and payment methods, customer demographic, age, gender, location, and preferences, and website clickstream, pages visited, time spent on each page, interaction patterns, and click events. Data collection, generating synthetical retail data, transaction, purchase history, amount, timestamps, and demographic, age, gender, locations, click stream, pages visited, time spent on each page, and click events. Now we see the code. Import pandas, manipulation and data frame creation, NumPy for numerical operations, data time and time dealt for data and time manipulation, and random for random numbers. The data set is 1000. Generate random customer IDs are generating ranging from 1 to 10, and customer IDs and random radiants. There will be 1000 IDs with possible repetition. Random transactions amount between $5 to 500 and guaranteed and rounded in 2 decimal places. A start date 1 year ago from 2 days calculated, then for each record a random data within the last year is generated. Random age between 18 to 70 generated. Random genders are assigned, male and female, and random locations, urban, suburban, and rural. And then generate random website clicks. Random number for website click between 1 or 50 are generated. Random time spent between 1 to 300 and and all generated data is combined into pandas data frame with appropriate column names. The first few rows of the data set are printed to the console to verify the generated data, and these are data, and these all are age and transaction, genders, and clicks, how much time they spend, all are there. Data preparation, cleaning and pre-processing data to ensure quality and consistency. This involves making raw data suitable for analysis by addressing issues like missing values, outliers, or inconsistencies. Importance of data preparation. Proper data preparation is crucial for building accurate and reliable predictive models. Impact: well prepared data leads to better model performance and more trustworthy insights. Main step of data preparation: data cleaning, handling missing values, removing duplicates, correcting errors. Data transformation, normalizing, scaling, encoding categorical variables, feature selection, choosing relevant feature for the model. Data preparation, the techniques: handling missing values, imputation or removal, removing duplicates, ensuring unique records, correcting errors, fixing or removing erroneous data. And this is the code. Import panda again, and panda this is the data framework, and the missing values in the size columns are in place true in the column, and the missing value in the bedroom columns are the filled with the median or existing values in the columns. Any duplicate rows drop out are removed. Rows with non-positive values are removed. They ensure all prices are, and the pre-processed data frame is printed to console, and this is the result from us. After the pre-processing steps, the data frame will look like this. The missing value in the size volume is replaced, and the missing value replaced, and you can see here all the columns are filled, duplicate rows are removed, any rows with the non-positive prices are removed by the following in the data table. Data preparation, data transformation to normalize, scale and encode data for model compatibility, techniques, normalization, scaling, standardizing the range of independent variables. Okay, so Panda again, and then the data, that is the data setup. Define synthetic data set, data representing housing feature, area, bedrooms, bathrooms and price. Feature separation, separate the price X from the target price by dropping the price column using d of f of price. X is 1, that leaves us with the only the independent variable X. Scalar definition, initiate sender scalar object scalar, which will standardize the feature by removing the main and scaling unit variables. Optional, convert to data frame, convert the scale array X scale back to the data frame X scale of the for easier inspection and further processing. Output scale data visualization and for verification. And this is the data output. Data preparation, encoding categorically variables, covering categorically data into numerical format. Again, import necessary libraries, pandas and data handling, one hot encounter from scalars, preprocessing for categories encoding. Data setup, define a synthetic data set representing housing, feature, bathroom, price. Feature selection is separate the feature X from the target price by dropping the price column using the df of drop price X is 1, that leaves only with the independent variables. Fit and the encoders definition, instantiate the one hot encoder object encoder to convert category variable into format. Fit and transform category features. Use encoder fit dot transform xct to fill the encoder to the categorical feature city and transform into a spare matrix of one hot encoded values. Optional, convert to data frame inspection and further processing, use encoder get feature names city to retrieve column names of the encoding features, and then concrete encoding data remaining features. Combine the encoded data frame X encoded df within the removing feature of X excluding city, use pd.connect. And this is output processing data X process of visualization and verification, and this is the result of encoding category variables. Data preparation, feature selection to identify the most relevant feature that contribute to model's accuracy. This can help improve model performance, reduce overfitting and decrease training time. Techniques, filter methods. These methods use statistical techniques to evaluate the importance of each feature independently of the model. Correlation means the linear relationship between each feature and the target variable. Highly correlated feature with the target and consider more relevant. P-values used in hypothetical testing to determine the significance of each feature. Feature with low p-value are considered significant. Filter methods, quick and independent of model training, useful for preliminary feature selection. Wrapper methods, these methods evaluate feature subset by training a model on them and assessing model performance. Recursive feature elimination, REF, iteratively removes the least important feature based on model performance until the optimal number of features is reached. more computationally intensive but can yield better result on they consider feature interaction. Embedded method. These methods perform feature selection during the model training processes. Lasso regression adds a penalty equal to the absolute value of the magnitude of coefficients. This can shrink some coefficient to zero, effectively performing feature selection. Integrate feature selection with model training, balancing between filter and wrapper methods in terms of performance and computational cost. Data pre-feature selection, data setup. Uh, Before diving into each technique, let's have the synthetics, housing data and processing. Import again necessary libraries, pandas, stand scalar on one hot encoder, column transformer, and pipeline. Data setup, define a synthetic data set with housing feature and the target price. Create a data frame for this data. Features and target, separate the x and y different. Pre-processing pipeline, define pipeline for pre-processing numerical and categorical features. Use standard scalar for numerical features and one hot encoder for categorical features. Column transformer, combine the pre-processing steps with the column and apply pre-processing. Fit and transform the pre-processing pipeline for the feature and Carnival for the result of the data frame. And this is the result, pre-processing data. The goal of feature selection is to identify the most relevant feature that contribute to the predictive model's accuracy. This can help improve model performance, reduce overfitting, and decrease training times. Filter methods using statistical test technique to evaluate the importance of each frame independently of the model. Correlation measures the linear relationship between each feature and the target variable. Highly correlated features with the targets are considered more relevant. P-values used in hypothesis testing to determine the significance of each feature. Features with low p-values are considered significant. Quick and independent of model training, useful for primary feature selection. Again, for description is skilled KB set and F regression. This one, feature selection setup, initialize the selector and with the skilled KB rest using regression as the sorting function and selecting K2. This one, K2 best features. Fit and transforms applies selectors fit transform to X pre-process and Y to perform feature selection based on statistical tests. Selected feature, retrieve index of selected feature using select get spot indicates. And finally, maps are these indicate correlating. Corresponding feature names in all feature names. Print the selected feature, identify the filter method using F regressions. This. Data preparation and feature selection. Another part, wrapper methods using recursive feature elimination. The goal of feature selection is to identify the most relevant feature that contribute to the predictive model's accuracy. This can help improve model performance, reduce overfitting, and decrease training time. Wrapper method. These methods evaluate feature subsets by training a model on them and assessing model performance. Recursive feature elimination, already discussed. RFE iteratively remove the least important feature based on model performance until the optimal number of feature is reached. And then RFE, important statement, import RFE and linear regression from sklearn feature selection and sklearn.line model. Wrapper method is used in the initialize model as a linear regression instance. Setup of RFE methods specifying model and n feature to select two best feature. Fit and transforms. This one applies RFE.fit transform to X preprocessed and Y to perform recursive features elimination. This one. Selection feature retrieve indicates selected feature using regular support. This one. And print the selected feature identified by the wrapper method using recursive method elimination with linear regression. Integrate features selection with model training, balancing between filter and wrapper methods. Embedded method using lasso regression. Embedded method, these methods perform feature selection during the model training process. Embedded method integrate features selection with model training, balancing between filter and wrapper methods in terms of performance and computational cost. Again, important statement, import Lesco CV and select form model from the sklearn linear model and sklearn feature selection. Embedded method initiates Lesco with lasso CV using CV5 for cross validation during lasso regression. Fits Lesco X preprocessed and Y to determine feature importance. Feature selection, create model specifying Lesco in the model preferred true, this one, and indicate lasso is already fitted. Transform X preprocesses using model transform to select feature based on Lesco regression. Selected features retrieve indicates selected features using model.get indicates true. Map with use indicate to corresponding feature names in all feature names. Print the selected feature identified by the embedded method of our Lesco regressions. This. Summary of data preparation. Recap: data preparation involves cleaning, transforming and selecting features. Proper preparation is crucial for accurate and reliable predictive models. Use techniques to address data issues, normalize and encode data and select relevant features. Model building, the process of using statistical and machine learning techniques to create predictive models. This involves selecting and training algorithms to predict feature outcome based on historical data. Importance of model building. Crucial step: building accurate predictive models is essential for making reliable predictions. Impact: the choice of model and its training significantly affect the quality and performance of predictions. Techniques for model building: statistical techniques, linear regression, logistic regression, time series analysis, and machine learning techniques, decision tree, random forest, support vector, machines, neural networks. Steps in model building: define the problems, identify the type of prediction required, regression or classification, select the model, choose the appropriate statistical or machine learning techniques, train the model, use historical data to teach the model pattern and relationships, validate the model, test the model's accuracy and performance using unseen data, refine the model, improve the model based on validation results. Model building techniques: Statistical techniques, linear regression models that relationship between a dependent variable and an independent variable using a linear equation. Predicting scale based on advertising spend and historical sales data. Logistic regression used for binary classification, predicting the probability of an event. Identifying whether a customer will buy a product based on demographic data. Time series analysis data points collected over time to identify patterns and make forecasts. Forecasting stock prices or predicting seasonal sales trend. Machine learning techniques, decision tree, hierarchical tree structure that recursively partition data based on features. Predicting loan default risk based on customer credit history and financial status. Random forest ensemble method combining multiple decision tree for improved accuracy. Detecting disease based on medical test results and patient history. Support vector mechanism SVM finds optimal hyperplane to separate data points into classes. Classifying email as a spam or non-spam based on content and sender information. Neural network models inspired by the human brain, capable of learning complex patterns. Autonomous driving system interpreting traffic signs and road conditions. Model building statistical techniques, linear regression. Linear regression model that relationship between a dependent variable and independent variable using a linear equation. Predicting sales based on advertising spend and historical sales data. So we generate synthetic data. ठीक है जी, this one. And then this is the data for preparing modeling, convert generated data in a pandas data frame df with column for features and target variable price. Then select features and target variables, this one, and define feature x and the y from the data frame df. Split data, divide into this one, split data, divide into the training and testing set to train the model on one set and evaluate the another one. And then create and train the model, instantiate the linear regression model and train it using training data x train and y train, this one, and make prediction, this one, the train model to predict house price, y peaked, this one, and on the test set x text. Evaluate model performance, measure the model's accuracy using mean squared error, MSE, this one, MSE, between predicted and actual house prices, y text and y, this one, providing a quantitative assessment of the model of effectiveness. And this one is the result. Linear regressions 2430.314. Model building statistical techniques, logistic regression, and here used for binary classification, predicting the probability of an event and identifying whether a customer will buy a product based on demographic data. So generate synthetic data, this one, and xy, where x represent feature influencing a binary outcome and y represent the target classes, this. Split data into training and testing, divide synthetic data into training and testing set to train this model on one set, evaluate the another one. Create and train model, initiate a logistic regression model and train it using the training data x train and y train, and make predictions, use the trained model to predict classes y predict and x text. Evaluate model performance. Assume the accuracy of the model using accuracy score comparing predicted classes Y PRD, this one, and Y test, providing a measure of the model's predictive power. Result logistic regression 0.955. Model building statistical techniques. Time series analysis. Analysis data points collected over time to identify pattern and make forecast. Forecasting stock prices or predicting seasonal sales trend. So generating system data, this one, and simulate time series data, dates, values representing hypothetical measurement over time. And then fit ARIMA models. Apply an ARIMA model to the time series data is data, and specify order 111 reflecting the model's outrageous differences and moving average components. Forecast feature values. Predict feature values forecast using the fitted ARIMA model. Resulting forecast steps 3.0. Projecting trends beyond the observed data. And visualize the original time series data. Fitted values results, fitted values and forecasted values forecast using the matplotlib for visualization, adding the understanding trends and predictions. And this is the graph ARIMA forecasting. Model building, learning techniques, decision tree, hierarchical tree structure that recursively partition data based on feature, and predicting loan default risk based on customer credit history and financial status. And here you can see import libraries, and then we generate synthetic classification of 1000 which has a 10 features, and split data X train, Y train, and all these things, and then train the decision tree model, this one tree models, and make prediction and evaluate model performance. So this one is the result. Model building, machine learning techniques, random forest. Ensemble method combining multiple decision trees for improved accuracy, detecting disease based on medical test results and patient history. So generate synthetic data here 1010 and XYY, and split data into training and test, divide the synthetic data into training and testing set to train the models on one set and evaluate another, create and train model, instant random forest classifier model, and train it using training X train and Y train random forest. Make predictions here, and Y X text, use a train model to predict classes Y and X predict. Evaluate model performance, assess the accuracy of the model using accuracy score, comparing predicted classes Y predict and then Y test, providing a measure of the model's predictive powers. And this one is the result. Model building, machine learning techniques, support vector mechanism, machines, SVM. Find the optimal hyperplane to separate data points into classes, classifying email as a spam or non-spam based on content and sender information. So this one scale generating classification 1000, feature 20, and random straights XY. From here split data into training a test, divide the synthetic data into training and test sets to train the model on a one set and evaluate it another one. Create and train model instant SVC sport vector classifier model with a linear kernel and train it using training data X and Y train. Make predictions, use the train model to predict, classify Y predict and SVM model and then X test. Evaluate model performance, assess the accuracy of the model using accuracy score, predicted class Y predict and actual classify test, providing a measure of the model's predictive powers. So this one is the result 0.96 SVM. So modeling building steps define the problem. Begin by clearly defining the type of prediction needed, whether it involves predicting numeric values, regression, or categorically classification. This step ensures that the model aligns with the specific goal of the analysis, such as predicting sales volumes or classifying disease based on symptoms. Select the model. Choose an appropriate statistical or machine learning techniques that suits the defined problem and data characteristics. Factors include the complexity of relationship in the data, interpretability requirement, and the amount of available data. Train the model. Use historical data to train the selected model, allowing it to learn patterns and relationships from past observations. Employ algorithms to fit the model parameters on the training data, adjusting for accuracy and generalizability. Validate the model. Assess the model's performance using unseen data validation dataset to gauge its accuracy and reliability in making predictions. Evaluate using metrics appropriate to the problem type, such as mean square error for regression or precision and recall for classification. Refine the model. Iterative process improves the model based on validation result and insight gained during testing, enhancing its predictive powers. Adjust model parameters, feature selection methods, or data preprocessing steps to optimize performance. Model evaluation introduction. Definition. Model evaluation is validating the accuracy and performance of predictive models. Ensure that the model makes accurate prediction and can generalize well to new unseen data. Accurate and reliable models are crucial for making informed decisions and achieving desired outcome in predictive analytics application. Overview of model process. Train, test, split, divide data into training and testing sets. Cross validation. Use multiple split to get better assessment. Performance metric. Use number to see how good the model is. Model evaluation process. Train, test, split to evaluate model performance on unseen data. The train, test, split in the simplest model evaluation approach, where we divide the dataset into two parts, one for training the model and one for testing it. This helps in assessing the model's ability to generalize. Process of train, test, split. Randomly split the dataset into two parts. Training set typically 7 to 80% of the data, and testing set the remaining 20 to 30%. By separating the dataset into training and testing set, we can train the model on one part and evaluate its performance on another, ensuring that the model's performance metrics reflect its ability to handle unseen data. Advantages and disadvantages. First advantage is simple and easy to implement, quick assessment of the model performance, and disadvantage, performance highly dependent on the choice of the split, may not represent the full dataset variability. While the train test split is straightforward and fast, its result can vary significantly depending on how the data is split potentially, leading to misleading conclusions about the model's performance. Cross-validation: use multiple splits to get a better assessment. Cross-validation improves upon the trained test splits by using multiple trained test splits, thus providing a more comprehensive evaluation of the model's performance. Types of cross-validation: k-fold cross-validation. Data set is divided into k subsets. Model is trained on k1 folds and tested on the remaining fold. Process is repeated k time. Leave one out cross-validation. Each observation is used as a test set exactly once. Computationally expensive but thorough. K-fold cross-validation and low CV are popular methods. A K-fold cross-validation is practical and balances the trade-off between computational efficiency and evaluation reliability. Leave one out cross-validation, while thorough is often too resources intensive for large data sets. Advantages and disadvantages. First, advantages: more reliable performance estimates and using all data for training and testing. Disadvantages: computationally more expensive than a simple train test split, longer training time due to multiple model fittings. Cross-validation provide a more robust evaluation, but the cost of increased computational resources and time, as the model needs to be trained and evaluated multiple times. Model evaluation. Summary of model evaluation. Model evaluation is crucial for validating the accuracy and performance of predictive models. Different metrics are used for regression and classification models. Proper evaluation ensures the model generalizes well and makes reliable prediction. Help in selecting the best model and improving its performance. Train test splits, cross-validation, and performance metrics are critical steps. Continuous evaluation and refinements are essential for maintaining robust and reliable predictive models. What is model deployment? Model deployment is the process of making a machine learning model operational within a production environment to generate predictions or new data input. It involves integrating the model into existing system so that it can be used to support decision-making processes. Importance of model deployment. Model deployment is crucial because it bridges the gap between data science and business impact. It allows organizations to derive actionable insights from their data and automate decision-making process based on predictive analysis. Deployment steps: model training, data preparation. Before training a model, data must be cleaned, transferred, and split into training and testing sets. This ensures the model learns from reliable data. Model selection: choosing the right algorithm based on the problem at hand and the characteristic of the data. Training the model: fitting the selected model on the training data to learn patterns and relationships. Validation techniques. Cross-validation: dividing the data into multiple subsets for training the model on several combinations of these folds or evaluating its performance on the remaining data. Holdout validation: splitting the data into training and validation sets, training the model on the training sets and assessing its performance on the validation set. Performance metrics. Accuracy: measure the proportion of correctly predicted instance among the total instances. Precision in recall: precision measure the proportion of true positive predictions among all positive predictions, while recall measures the proportion of the true positives predicted correctly among all actual positives. F1 score: the harmonic means of precision and recall, providing a single metric that balances both. ROC AUC: receiver operating characteristics. ROC: curves and area under the curve. AUC: assess the model's ability to distinguish between classes. Serialization technique. Serialization is the process of converting an object into format that can be easily stored and later reconstructed. In the context of the model deployment, it involves saving the trained model so that it can be reused without retraining. Common formats. Example includes pickle and joblib for Python, which serialize Python object efficiently. Deployment environment setup. Choosing the environment, organizations can deploy models on premises, in the cloud, or through a hybrid approaches, depending on factors like data sensitivity, scalability, needs, and existing infrastructure. Infrastructure requirement. Deploying a model requirement a deep server capacity, storage of the data and models, and reliable network connection to ensure seamless operation. Deployment platform. Popular platform like AWS, Amazon Web Service, or Azure of Microsoft, Google Cloud, Kubernetes, and Docker offer robust environment for deploying and managing machine learning models. Integrated method API endpoints. Deploying models as web service accessibility via HTTP endpoints, enabling real-time prediction from applications. Batch processing. Performing prediction in bulk on a schedule or as needed, suitable for processing large volume of data. Real-time streaming. Handling continuous data streams and generating prediction in near real time, often used in IoT applications. Tools and frameworks like Flask and Fast API simplify the development of API endpoints for model deployment, while platforms like TensorFlow serving and TorchServe specialize in serving deep learning models. Monitoring metrics. Latency, the time taken to process each predicted request, influencing application responsiveness. Throughout the rate at which predictions are processed, ensuring the model can handle peak loads. Error rates. Monitoring the frequency of prediction error or discrepancies between expected and actual outcomes. Tools for monitoring. Prometheus and Grafana, popular tools for monitoring and visualizing metrics related to model performance and system health. ELKstrack, used for logging and analyzing logs, providing insight into model behavior and performance over time. Model retraining, handling model drift, adapting models to change in underlying data distribution over time to maintain predictive accuracy. Automatic retaining pipelines, establishing continuous integration and deployment. C1 CD pipelines to automate model retaining and deployment updates based on new data. Deployment challenges. Scalability, ensuring the model infrastructure can scale to handle increased demand and larger data sets efficiently. Security, protecting models data from unauthorized access, ensuring compliance with data privacy regulations. Compliance, adhering to legal and regulatory requirements governing the use of data and predictive models such as GDPR, General Data Protection Regulation, or HIPAA, Health Insurance Portability and Accountability Act. Integration complexity, overcoming challenges related to integrating machine learning models with existing IT systems and workflow, ensuring compatibility and seamlessly operation. Deployment best practice, visioning models, maintaining a clear visioning system for model to track changes, improvement and update over time. Logging and auditing, recognizing and model prediction inputs and output for auditing purposes, enabling traceability and accountability. Collaboration, involving cross-functional teams, data scientists, IT operation, business stakeholders throughout the deployment process to ensure alignment with business goals and requirement. Documentation, creating comprehensive documentation covering model architecture, deployment procedure, maintenance protocol, and troubleshooting guidelines to facilitate future updates and acknowledge transfer. Top 5 programming language in data science. To excel in data science alongside statistical and mathematical skills, proficiency in programming languages is essential. Here are the top 5 programming languages crucial for data science. First is SAS, Statistical Analysis Systems. Uh, SAS is a proprietary software suite for advanced analytics, statistical analysis, and data management. Role in data science, preferred for its robust statistical capabilities and reliability in enterprise environments. Applications used extensively in predictive modeling, business intelligence, and data visualization. Example is conducting regression analysis on historical sale data to forecast future trends. SQL structures query language. SQL is a database language used for retrieve and manipulate data from relational database. Role in data science, essential for querying, updating, and managing database, crucial for data retrieval and integration. Application used in various databases like SQLite, MySQL, and PostgreSQL. Example, querying customers' data from a CRM database to analyze purchasing patterns and customer behaviors. Scala. Overview. Scala is a JVM-based language combining functional and object-oriented programming features. Role in data science, ideal for handling large-scale data processing and integration, often used with Apache Spark. Application suitable for distributed computing and real-time data processing. Examples, analyzing streaming data for IoT devices to detect anomalies in real time. R language. R is a language specifically designed for statistical computing and data visualization. Role in data science, preferred for its extensive statistical libraries and visualization capabilities. Application used for exploratory data analysis, statistical modeling, and generating visual insight. Example, creating interactive visualization to explore trends in public health data for epidemiological studies. Python. Overview. Python is a versatile high-speed programming language known for its simplicity and readability. Role in data science, widely adopted for data manipulation, machine learning, and statistical analysis. Application support numerous libraries, NumPy, Pandas, scikit-learn for data analysis tasks. Examples, building and deploying machine learning models for sentiment analysis on social media data. Choosing the right programming language depends on specific project requirement, data complexity, and team expertise. Each language offers unique strength in handling data from MySQL database querying to Python's machine learning capabilities and R's statistical powers. Majority of these languages equip data scientists with the tool needed to extract actionable insights and drive informed decision making in diverse fields. Why Python for data science? Understand the reason why Python is preferred language for data science due to versatility and flexibility, rich ecosystem, ease of learning. Versatile and flexibility, Python supports complex mathematical computation and efficiency, handles large data set. Its versatility allows data scientists to perform a wide range of tasks from data pre-processing to advanced modeling. Rich ecosystem, Python boasts a rich ecosystem for libraries specifically designed for data analysis and visualization. Libraries like Pandas, NumPy, Matplotlib provides powerful tool for manipulating data and creating insights visualization. Ease of learning. Python's simple syntax and readability makes it accessible for beginners. Its straightforward structure allows newcomers to quickly grasp fundamental concepts and start building their data science skills. Python libraries for predictive analytics. Python is a preferred language due to its simplicity and extensive libraries. NumPy, Pandas, Matplotlib, Seaborn, Skillet, Learn, TensorFlow, and Keras. Using Pandas for data manipulation, Seaborn for data visualization, and Skitlearn for building predictive models. Creating synthetic data for predictive analytics. Synthetic data is artificially generated data that mimics real-world data. Creating synthetic data is a powerful tool in a data science and machine learning, particularly when working with sensitive data, limited data, or specific scenarios that require controlled experimentation. Here is a detailed explanation of how and why to create synthetic data with examples using Python. Privacy and security protect sensitive information. Synthetic data allows the use of data that mimics real-world scenarios without exposing sensitive or personal information. This is particularly important in fields like healthcare and finance, where data privacy regulations like HIPAA and GDPR are stringent. Data augmentation. In many machine learning tasks, especially in deep learning, having a large amount of data is crucial. Synthetic data can augment real dataset to improve model performance. Control experiments allows for controlled experiments and testing scenarios. Synthetic data allows researchers to create control scenarios to test specific hypotheses or to debug model. Overcoming data scarcity. In scenarios where collecting real data is difficult, expensive, or time-consuming, synthetic data can provide an alternative. Testing and benchmarking. Synthetic data can be used to test the robustness of models and algorithms under different conditions, ensuring they perform well in various scenarios. Role of data science in predictive analytics. Step to create synthetic data. Define the structure and attributes of the data. Generate random values for each attributes and combine the values into a dataset. Identify the purpose. Understand the purpose of creating synthetic data, machine learning training, software testing, privacy preservation. Determine the data structure. Identify the types of data needed, tabular, time series, text. Decide the format for the data, example CSV, JSON, SQL. Specify attributes. List of all necessary attributes, name, age, salary. Determine the data type of each attribute, example integer, strings, data. Choose a randomization methods. Decide on a method to generate random values. Random number generation, sampling from existing dataset, statistical distributions. Implement random values generation. Use programming languages or tool to generate random values. For example, Python or R, MySQL. Libraries such as NumPy, Faker, and Skitlearn can be helpful. Ensure realism. Apply constraint and distribution that reflect real-world data. Realistic range, typical distribution. Consider inter-attribute dependency, like salary related to age, department related to job role. Organize data into desired structures. Arrange data in rows and columns for tabular data. Use nested structure for JSON or other hierarchical formats. Validate the dataset, check for missing values and inconsistency, ensure all attributes meet the defined criteria and constraints. Save the dataset, export to the required format. Example CSV, JSON. Ensure the dataset is easily accessible for further use. Case study: predicting house prices. Step 1: import libraries. We need to import several libraries that will help us create the dataset, manipulate it, build a predictive model and evaluate the model's performance. First, we need to import the necessary libraries. NumPy used for numerical operation, pandas for data manipulation, matplotlib used for plotting graphs. Then train test, this one from skill and model selection used to split the data into training and testing. That linear regression from skill and linear model used to create a linear regression model and then used to evaluate the mean squared performance here. Output, no output for this step as it is just importing libraries. Step 2, create synthetic data. We will create a synthetic data set with random values for features like the number of bedrooms, house size in square feet, and the age of the house. Based on these features, we will also create a target variable price. The code is, and then you see NC random seed 42, number of samples are 100, define the number of sample, bedroom size, price, and age, value of the size. And then we go for PD data set from here and create the data frame for the generated data and print the first 5 rows from the data set. And this is the data set, first 5 rows, bedrooms, size, age, and price. Data preparation, we need to prepare the data for training by splitting it into feature X and the target variable Y. We then split the data into training and testing sets. The code is prepare the data for training test X, bedroom size, age, and then select the features, and Y is the price. And then we have a train test split the data into training and lasting is 20 or 8 to 80%. And this is the results from here. Train the model. We will create a linear regression model and train it using the training data. The code is okay. So train a linear regression model, model linear regressions, and create a linear regression model, and then X and Y train the model with training data. And finally coefficient, we need to find the features and then model interpret, print the interpret of model. And this is our coefficient results and intercept result. Step 5, make predictions. We use the trained model to make prediction on the test set. Model predict X test and X text prediction for a test less, and then the 5 is the 5 predictions, and these are the 5 predictions. Step 6, evaluate the model. We evaluate the model's performance using mean squared error MSE, which measure the average squared difference between the predicted and actual values. Code and mean square error, let Y and test P calculate the mean squared errors between the actual and predicted values, and this one mean squared error is MSE, print the mean squared error, and this one is the result. Predictive analytics case studies. For your homework you need to pick any one. Predictive customer analytics, crime prediction and prevention, energy consumption optimization, fraud detection and prevention in finance, transportation, improving route optimization, health care, diagnostic and treatment personalization. References. Thank you. Please review the case studies and submit your solution. Sometimes questions are more important than answers. Waiting for your questions. More about me. Closing remarks, data science. Today we started by exploring the fundamentals of data science, understanding its core concepts and significance. Predictive analytics, we then move on to predictive analytics, examining its role in forecasting future events and trends and its practical applications. Python, we highlighted key Python libraries, demonstrated their practical use in building effective models. Case study, to connect it theory with practice, we view a case study that helped bring together the concept we discussed. Final thought, I look forward to see how you apply these techniques in your future projects and which we assign the case study to you. These are references. Or more